Good morning to everyone joining us from the West Coast. Good afternoon to everyone joining us on the East Coast, and good evening to everyone joining us from Europe. Welcome to the NEO Technology webinar series. Today, we're going to be talking about an introduction to Spring Data Graph with Neo4j with the presenter Michael Hunger. Michael Hunger has been passionate about software development since his childhood days in East Germany. He is particularly interested in the people who develop software craftsmanship, programming languages, and improving code. While he likes coaching and in-project development as an independent consultant, better software developer evangelist, he really enjoys numerous other projects in his life, and we are very proud at Neo Technology that he is the German division of the Neo4j project. Before we get started, I'd like to briefly introduce you to some features of the webinar system. On the right-hand part of your screen, we have a question box. Please feel free to type in your questions at any time. At the end of the webinar, we will have allotted time to answer your questions. If you don't think of a question during the webinar, but one comes to you later, or you want more time to think about your question, please feel free to go to the discussion forum on the Neo4j website at neo4j.org. And if you put questions up there, then you will have the whole community able to answer them. I already know what the most commonly asked question is going to be. It's, are you making a recording of this webinar? And the answer is, yes, we are. And as soon as we upload the recording to our YouTube channel, we will send a link to it out to everyone who has shown up for the webinar today, and we'll also post a link to it on our somewhere on our community website. Without any further ado, let me now turn the podium over to Michael Hunger. Michael, please take it away.
Thank you, Adam, for the introduction, and welcome everyone to the Spring Data Graph webinar. This is part of the monthly webinar series, so you can tune in every month for a Neo Technology webinar. So without any further ado, let's get started. Oops, sorry. Adam also already did the introduction, so I just skipped this slide. In this webinar, we will cover mostly Spring Data Graph, so I'll say some few words about NoSQL and Neo4j just to get the basics that are needed for understanding Spring Data Graph. But if you need more information about both those topics, just go to video.neo4j.org and look at the other webinars that have been recorded. We have got a lot of content, so it will be a kind of whirlwind tour through the content. And if we've got some time at the end, there will be a Q&A section. Otherwise, all your questions will be answered in a follow-up blog post, so don't hesitate to ask any questions that you would like to ask, and we'll answer them afterwards in written form. Our topic today is a quick NoSQL overview, just to put Neo4j into perspective. A Spring Data overview. Spring Data is the parent project of Spring Data Graph. A quick Neo4j intro, just to get the basics, and then the largest part of the webinar will be about Spring Data Graph. About NoSQL. So what does NoSQL stand for? It doesn't stand for No to SQL. It's also not Never to SQL. It is not only SQL. So we see NoSQL as polyglot persistent. So whatever kind of data you have, whatever task you have for your data, choose the best tool that you can choose for that. And that might be a SQL database, it might be a NoSQL database. It depends. And to use the right tool for the job is more important than just making everything fit into one system or one approach. So we have databases, right? And we can query them. And for certain databases, it's not so easy, so you can kind of see in this cartoon, so how do I create database? It's not database, it's a key value store. And how do you create the key value store? You write a distributed function in Erlang. So, and yeah, the solution is not so easy. We encounter several trends in NoSQL right now, or in general right now. First is that the size of your data is growing more and more. So mostly through big amounts of user-generated content and also mashups of large data sets. Then another trend that's really important is that data is more and more connected. So every time you click on a +1 button somewhere or a like button somewhere, you create new relationships between existing data, and that's a really important concept. And of course, data is no longer kind of strictly structured like in a payroll system where you just have one structure-free data and everything fits in, but due to user-generated content and dynamic content generation, it's often quite schemaless. And of course, you have changes in architecture from monolithic systems to loosely coupled service-oriented systems that are rather orchestrated and just built in one big box. So I'm going to skip some slides. So we had some issues setting up the Keynote and GoToMeeting software. So I have Keynote in a weird presentation mode. So it shows some slides that shouldn't be shown, and I just skip those. Data size, growing, connectedness, and semi-structured stuff. The architectures, and what I want to talk about is the 4 categories of NoSQL stores. We first have key-value stores like Redis, React, and Voldemort, and Memcache. We have column family stores like Cassandra and HBase, which are kind of like relational stores, but with a schema per row. We have different schemas per row. And document stores who are really great at handling, for instance, a tree-structured content like MongoDB and CouchDB. And of course, graph databases like Neo4j and others. I don't want to go into all the types, as I said, but just put the graph database into perspective. For the perspective, this is quite important. So we have on the y-axis the size of the data, and on the x-axis the complexity. So with large size data sets but low complexity, key-value stores handle data best. And with growing complexity, you need also a data store that is able to handle this complexity. And this is naturally a graph database. On the other hand, even if some applications and customers claim their data size is so large you can't use anything else than a key-value store, most of the use cases still can be easily covered by graph databases who can still handle billions of entities in a single instance, so that most of the use cases are still quite simple to put into a graph database anyway. A quick Spring Data overview. Spring Data is an initiative by SpringSource to bring the easy and convenient access to underlying persistence mechanisms to Spring developers. So most of you certainly know the JDBC persistence part of the Spring framework, which is very convenient to use, much more convenient than the original JDBC API. And to bring some of this ease of use and also API abstractions to Spring developers, the Spring Data project was started with Mark Pollack, the author of Spring.NET, as the project lead. And some aspects that are covered by the Spring Data project are, as I said, non-relational databases in general, helpers for MapReduce functions, the NoSQL support of Grails. Then the thing that we want to cover with polyglot persistence is cross-store persistence, so you don't have just one storage mechanism in your application but multiple, and you want to unify them in your domain model, in your data model. You don't want to have separate data models per store, but want to have a unifying data model. Then there's some infrastructure provided by the Spring Data project, like a basic support for mapping objects to other representations or serialization. So it deals with all the stuff around reflection and structuring the objects and object networks. Then there's some interesting infrastructure regarding repositories, so DAO repositories, where you can easily define your domain level repositories just by declaring some interfaces. We'll show that later in the Spring Data Graph section. And of course, there's ongoing or upcoming support for Spring Rule that I'll also talk about later on. There are Spring Data projects for the different types of stores, and there's a homepage for this Spring Data project where you can find details about it. VMware SpringSource collaborated with some of the vendors like Neo Technology and others to provide support for the Spring Data projects, but Neo Technology is the one company who did like the most of the work on their own. For all the other stores, SpringSource implemented most of the code that was there. Focusing on Spring Data Graph, so we've been collaborating with VMware around Spring Data Graph for more than a year now, and we want to put a improved programming model into use there that is using annotations and AspectJ to model really simply your POJOs as graph entities and allow you to access the graph database in a really easy way. And of course, we also want to support cross-store persistence. That means that you can just take your existing JPA application and enhance it with graph-related data. And we also provided row add-ons, several versions of those ever since we started working on Spring Data Graph. A quick tour through Neo4j. The first thing is Neo4j is a database. It's a graph database, but you can forget about rows and columns. But instead you have nodes and relationships, typed relationships, which are directed. And on both nodes and relationships, you can put arbitrary number of properties. An example for a graph is this one. That's me and David, who wanted to present with me today, and we both know Rod Johnson. And David drives a Honda and likes Chinese food. He works for Neotech, me too. And I live in Dresden, Germany. So you can put lots of different data in a graph database. It doesn't have to adhere to a single schema. You can have lots of different properties per node. So that's the schema-freeness of the graph database. Neo4j is written in Java. You can run it embedded or as a server and have integrated indexing and lots of language bindings. And it has been production ready for quite a long time now, and in different to other NoSQL data stores, it's a fully transactional asset database. And of course, due to its nature, it's very fast for graph operations. Neo4j is also whiteboard friendly, so it's easy to take a whiteboard, draw a picture, and turn it into a graph. Some code. This is creating, let's drag that out a bit. This is creating a set of nodes and setting properties on those nodes and creating a relationship between those. And as it's a transactional database, you just wrap the whole thing into a transaction. And there you go. So how do I create it? Using traversals. I create traversal descriptions for those graphs. And this is in Java. And there I specify how and which relationships are traversed. And I get a path in return. So from a starting node, I can get a path to the end nodes that are fulfilling these traversal descriptions. I can look up single nodes with indexing, and we have also a new feature which is really cool. That's the Cypher query language, which states how you want to, what you want to do with the graph, and not how you want to do it. With a traversal, you rather do an imperative way of declaring what you want to do, and here you just say, I want to have, for instance, the friends of a friends of David, which is 2 steps across along a node relationship. We don't care about the friend in between, just the friends of a friend, and filter those friends by age greater than 18. And we get a first node with an index lookup. There are also means of aggregating data, like counting a number of nodes in a relationship and aggregating properties of those. So this is very powerful, and you have to write a lot of Java code to do the same in the traversal framework. By the way, it's implemented in Scala, which is really nice to do that. There's a performance thing that's also covered in other webinars, and we have some graph algorithms and so on. So now to the core of the webinar, Spring Data Graph. First of all, I want to point out which Spring Framework conveniences are relevant for Spring Data Graph. So first, it's the POJO-centric application design. So with the advent of Spring, suddenly we had POJOs everywhere as services, as entities, whatever Spring means, and that made POJOs really kind of a first-level thing in applications. It's really nice. So Spring also made SPJ aspects socially acceptable, for instance, the transaction configuration with AOP and the configurable annotation, which allows you to inject instances of Spring Beans that are created with new. Of course, the template programming model that I already mentioned, that is used for persistence and other resource management APIs. Then the declaring your dependencies and having them injected instead of creating them all on your own is also important and comes into play when we look at the repository abstractions. And of course, Spring Java config and XML namespaces, which help you to reduce the amount of configuration that you have to write and abstract that very nicely. Of course, Spring brings along quite a lot of powerful libraries on its own and very nice library abstractions like the JDBC or Spring Web Services. And so that's very important, and that's also something that went into all the Spring Data projects to provide really nice abstractions over the underlying APIs. And of course, Spring brought along the Spring Data project, which is the parent project of Spring Data Graph as well. Oops, sorry. For an overview on Spring Data Graph, first a little bit of history. Spring Data Graph is the brainchild of Roy Johnson and Emil Eifram, the founder of the Spring Framework and the CEO of Neo Technology. Both of them came together and wrote an initial prototype of this library using aspects and annotations, and we continued to develop this initial prototype into what it's today, and with a really broad scope and lots of features which we will show you today. It uses annotations to define POJO entities. These entities are backed by the graph database, so unlike other persistent technologies, it's not working all the time with detached entities or copied entities, but it's kind of a live view of the graph database, so that you have read-through and write-through effects when changing properties of your entities. And we need to use SPJ for that to have these functions available. And we also provided a Spring Rule add-on. Some more features is we have the support for Spring Data Commons repositories. We support several types of graph queries like Cypher and Gremlin and Neo4j traversals, either on dynamic fields of your entities or via repository methods. We support the Neo4j indexing and have the entity type, so the Java type of your entity is also stored in the graph so that we can reconstruct the type whenever you fetch a node and want to convert it into an entity. And we can also assert that certain types are used in the correct way. But on the other hand, we also want to provide dynamic types. So whenever you take a node and want to project it to a different type, which perhaps shares some of the properties of this node, then you can do that. And then only those properties are available that your target type contained. We provide a cluster support that we show later, and also support for bean validation. An interesting and very important feature is support for Neo4j server, so REST API of the Neo4j server, because looking into the future into hosted Neo4j services that I'm also working on, it's more and more important to not interact with an embedded version of Neo4j, but with a Neo4j server that runs on a hosted platform, a cloud service, whatever. So you can use Spring Data Graph to run as a client to a server, but also to use it inside a Neo4j server to provide server extensions. And there's also a Neo4j template that comes with convenience methods and exception translation, transaction management, and more. So now we'll look at some of the features in more detail. First, the POJO-based, the annotation-based POJO mapping. So this is the way a Neo4j entity looked before we went into this Spring Data Graph project. So you had an underlying node which was passed in on construction, and then every property access, read access or write access was passed to the node. You can easily imagine that having a lot of properties will generate a lot of boilerplate code, and it will make your entities look quite ugly. So that's why we chose to have a different approach, which makes an entity look like that. You have an entity annotation, node entity annotation on top of the class, and then every field of this entity will be backed by the graph database, and you also see already an annotation that extends the previous model, previous class, by having this field automatically indexed. There's even more than that, so you don't need to do anything about relationships because these are also handled for you. And in manual code, it would be quite a lot of boilerplate code for finding relationships in your entities. So that's also, again, how would I work with relationships? How do I define an entity class for a node entity, which is kind of the main type of entities you would use? These are represented by a node and a graph, and its fields are saved as properties on the node, and references to other entities or collections of references to other entities are stored as relationships between nodes. Each node entity can be instantiated by using new, like any other POJO, and these node entities, these instances of these classes are also returned by lookup mechanisms like index lookups or query execution and so on. And this is possible by the type information that's stored in the graph. So you don't have to rely on you to provide the target type of the nodes you looked up, but we can look up it for on our own. There's a second type of entities, because relationships in a graph database are first-level citizens. These are also handled similarly to node entities, so you can also have any number of properties on a relationship and have them really used as an entity instance. So in a relational database, you would create an intermediate table for 1 to n or m to n cardinalities of relationships, and here in a graph database you just have a relationship, and that could be an entity as well. And we also support having start and end nodes of this relationship being annotated fields, so then whenever you access those fields, they will provide you the start and the end node. And so just having the Java class with the annotations doesn't look like much, because it doesn't do anything actually. Only when the AspectJ aspects kick in, they add all kinds of functionality around that. I will speak about that later. So first, let's look at the individual parts in detail. So primitive fields are mapped directly to Neo4j properties like strings and ints and numbers and so on. And for other fields that are now natively supported by Neo4j, we use the Spring conversion mechanisms and provide some conversions out of the box. For instance, enums and dates are converted out of the box, but you can add your own converters. So whenever you have some field that's of a custom type that you want to store as a Neo4j property, then you can also just add your own converters to your Spring config, and then it will convert those properties to an appropriate value in the graph database. Transient fields are not persisted like in other persistence mechanisms as well. So what about relationship? That's the more interesting part. So whenever I mention or put a another node entity as a field into a node entity, then whenever I access the field, it tries to find a relationship to that type from the current node. And if it doesn't find one, it just returns null. Otherwise, it returns the target entity. And whenever I set the field, then it creates a relationship and probably removes the existing relationship that was there before. So on the other hand, you also have, as you've seen, Neo4j relationships are directional, but you can navigate them anytime in the opposite direction. So if I have a relationship from movie to a top actor, then in the actor you can use the inverse relationship just by declaring the other direction and having the same type. So the relationship type defaults to the field name, but you can of course provide your own type to access the same relationship and just navigate it in the opposite direction. Here we can already see the annotation that it can be used to annotate relationship fields, either for single relationship fields or set-based or collection-based relationship fields. And there are several attributes on this annotation that you can use to declare your intent. For 1 to m, n, and m to n, so multi-relationships, you use a set type, and you can declare, for instance, the Neo4j relationship type that you want to use for that. Otherwise, it would just be movies in this case. And the interesting thing about the set, so you don't have to create a set on your own, it's just provided if you access the field. But that's not a regular set, it's a managed set. So whenever you remove entities from the set or add entities to the set, then your changes will be reflected in the graph. And if you clear the set, then all relationships will be removed. So it's very convenient to use. Relationship entities can be accessed a bit differently. So you have first you declare a relationship entity, for instance the role between the movie and the actor, because it also has a role name and perhaps something like the money they receive and others. And so we can declare the start and end nodes of this relationship entity with annotations and any number of properties we want to add to the relationship itself. And relationships can't be created on your own because they are provided by the graph database and will be created explicitly. So you can access those relationship entities via a different annotation that is called related to wire, and then you get back an iterable of these relationship entities that you can walk through and do things with those. And that's a read-only view, so you can't change it right now. So that's the current implementation at least. We might change that in the future. So as I said, the relationship entities work the same as node entities. Any property is mapped to the graph or converted, and the start and end node annotations denote the actually start and end node of the relationship in the graph. Indexing. So indexing is quite an important feature in a graph database because also a graph database is very fast at local graph operations. So when you have a start node or a set of start nodes to execute an operation, global operations are not the strengths of a graph database. So you would use any kind of indexing mechanism for accessing certain nodes in a graph database very quickly, either by using something like Neo4j like Lucene, or using a different key value NoSQL store like Redis or others for this. So in Neo4j it's a bit more to do to index a field and access an index. So in Spring Data Graph it's just putting an annotation on a field which allows you to index it automatically. So there has been auto-indexing support in Neo4j 1.4, but before that it was very inconvenient to add fields to indexes. And that also takes care if the value changes and updates the index accordingly. They can be looked up using repositories. We will look at repositories in more detail a bit later, but in general you just create a repository or get yourself one injected by Spring, and then the repository has methods for finding index entries in the graph database. So there's also the possibility of adding full text indexes, which allow you to do use text analysis for the queries, and these can just be added by adding a annotation attribute that says full text true. And the index name that is used defaults to the domain class name, so there are no collisions between different domain classes that have the same index keys, because index keys default to field names. So if I have actor names and, for instance, label names, then they don't conflict in the same index, but they use different indexes out of the box. Of course, you can define your own index names on the properties. So if you want to have any or all your domain entities in the same index to do, for instance, cross-entity Lucene queries, then you can use those. And we also support the Lucene query syntax if Lucene is used as an index provider, and range queries as well. So we've seen in the Neo4j introduction the graph traversal as a quick slide. So we can put graph traversals in Spring Data Graph, even in entities. So that's a nice example of a dynamic field. This is a field which is just computed by the library. So whenever you access the field, then a computation mechanism jumps in and creates the field value on the fly. In this case, it creates an iterable that represents the traversal, starting at the current entity and executing a traversal description that is provided by this traversal description builder. Unfortunately, Java annotations have severe limitations on what you can put into annotation attributes, so it's not so easy to just put an expression in there, so you have to put a class in there, and that's why we have this separate factory class for the traversal description. Actually, the build method of the builder gets passed in several attributes, several parameters that allow you to customize the traversal description that is returned. We saw Cypher as the experimental new query language of Neo4j, and we also support Cypher-based query annotations on fields, so you can have a field that just says, okay, whenever someone accesses this field, please execute this query and provide the return to the result as value of this field. The start placeholder is replaced by the current entity, and then you can also pass in the query annotation additional parameters that can be used to parameterize the query as well. So the first one is the Cypher query for co-actors of this actor, which also acted in the same movies as the current actor. And the second one is a query that shows you not just the co-actors, but the movie titles and the co-actor names as a iterable of a map of rows. So how do we use AspectJ in Spring Data Graph? It's very, very important to the annotation-based POJO mapping, because all the infrastructure code that allows you to just take an entity, annotate it, and then have a really complex entity under the hood is done by the AspectJ aspects. Just by adding an entity, an annotation to an entity, it does two things. First, it introduces an interface, an appropriate interface to the entity. That interface is called node-backed for node entities and relationship-backed for relationship entities. And on top of this interface, we use SPECJ introduction facilities to introduce additional methods and fields. For instance, the field for the underlying node and also fields for a graph database and so on. And we also introduce methods like relate to, which I show in a second, and find by query and so on. And also methods for persisting and deleting entities will be added by the SPECJ aspects. When talking about SPECJ, unfortunately, we have to talk about tooling because it is not as well supported as it should be, because it has been around for, I don't know, 15 years or so, almost. So quite a long time. And unfortunately, only with the latest versions of STS and Eclipse and the current AGDT plugin, all of the features of Spring Data Graph work. So we use some of the quite advanced features, and we also found several issues and bugs in SPECJ while developing this library. Unfortunately, in IntelliJ IDEA, it's in 10.5. You can compile and run Spring Data Graph projects, but there are still some editor quirks because it doesn't recognize, for instance, introduced methods. So you get some red arrow markers in your IDE. But we are working with the JetBrains guys to also put full SPECJ support in IntelliJ 11. So we have then no issues anymore. So with build systems, there are few problems. So either you can use Maven or Gradle or Arnd and Ivy. We provide either sample scripts or sample configurations or plugins for those, which happily compile and weave the SPECJ with your classes. So the aspects are in place after the build system completed its task. So much about the tooling aspect. So some words about introduced methods. So one method that is introduced to the entity is the relate to method, which takes a target node relationship entity type, so the class of a relationship entity, and the actual graph relationship type. So we can use it as shown below here, just to create an acts-in method that takes a movie and a role name and creates a relationship with the first call to the introduced relate to method, gets back the instance of the role relationship entity, and then can set any number of properties on the relationship and even return it. And so you can do even more things on it. Yeah. A second method that's introduced is find by query. So you can use queries inside your entity for accessing certain features or aspects of the graph. And this is just an example for Cypher, but there are also support for the other query mechanisms and traversals as well. So what would a graph look like? I create actors that creates nodes. We set properties on those actors. Those are also set on those nodes. And after that, we create relationships from both actors to the movie Fight Club, and that using the relate to method under the hood, and that just recreates the relationships in the graph as well. So there's a bit sad chapter about Spring Data Graph. Initially, we thought that it would be very easy to just assume that everyone uses those POJO entities inside of transactional contexts, so that we can assume that we always have a transaction context and can always access the Neo4j graph database in read and write modes. So it was quite easy to work with that, but we quickly discovered that the reality looks a bit different. So lots of people just create entities, use them for sometimes throw them away without never storing them. Especially that's common in web frameworks that creates entities all the time and just throws them away if they're not persisted and so on. And also other persistence mechanisms use this approach, and you also want to use entities without underlying storage, for instance in Unitas. So we had to introduce a lifecycle for entities, which has two states. Either you have an attached entity or a detached entity, and you can see in the following graph that you have a quite complex life cycle, or there are lots of transitions in the life cycle. Whenever you create a new entity, it's detached. When you want to, so you can modify the entity outside of the transaction, and it's still detached, so all the changes will stored in memory or just in the Java class instance. Whenever you go into a transaction, it's still detached, but if you call persist on the entity, it gets attached, and inside the transaction, then any modification will be right through to the graph and also available for graph operations like queries or traversals and so on. Because of the detached entities, if you do any changes on the entity and don't store them, these changes are not visible in the graph database. You can also just call persist outside of a transaction on an entity, then it gets stored, so it creates a new mini transaction and persists the entity, and then the entity is in an attached state. It's also in an attached state if you call persist inside of a transaction, and only if you start modifying the entity again outside of a transaction, it becomes detached again. Whenever you retrieve an entity from a lookup mechanism, it is initially attached until you start modifying it. So any field access is still going to the graph database as long as you didn't change this field. So whenever you change the field to a different value, this field will be read from local memory. If you didn't change the field, it will be read from the graph database. So that's not the most convenient way in general, but that was like the way we found it worked in most of the use cases that we encountered. Some words about the repository support in Spring Data Graph. So there's very nice infrastructure in Spring Data Commons for interface-based repositories, and it works like that. You just define the interface with generic annotation for your with a generic type for your domain entity, and add a namespace configuration in your Spring config, and then you get out-of-the-box support in your repository for CRUD operations, things like index lookup, traversal executions, and queries. And the nice thing about those repositories is that you can add any number of custom methods to the repository, and with just one implementation class you can provide the implementations for exactly those methods, and don't have to care about all these generic boilerplate methods that you don't want to write. So it looks like that. For instance, for a movie, I create an interface as movie repository, which is a graph repository, and that's all I have to do for just the default operations of the repository, and I just name the base package of my repositories in a namespace config, and after that, whenever I want to have one of those repositories injected, I just put the auto-wired or resource annotation for my injection, or I can also inject it via context lookup, whatever, and then I can just use it. For instance, this is controller, so it's web layer, and it gets a repository injected, and I can do an index lookup for the movie ID here and find a single movie and show it in a view. Other repository methods that are there for the basic stuff is getting single entities or finding traversals or having a paging support in here, which is now very nice also for clients, rich clients or UIs, web UIs, to have paged queries or sorted queries as well. We also added support with annotated methods and interfaces, so you don't have to write an implementation for that, just put the query that you want to execute with this method in an annotation, provide parameters with also annotations for their names, for the placeholders in the query, and then provide the return type, which also is inspected to provide the correct instances of entities that you want to have returned. And then whenever you access the method, the query is executed and you get the results back. You can also add pageable or sort as additional parameters to those queries. These will also be taken into account for the execution. So the first two queries are Zephyr queries. The last query is a Gremlin query, which is a Groovy-based DSL for graph operations, graph traversals. Neo4j template, we all know the Spring template pattern, GDBC template. The Neo4j template also does resource and transaction management, provides some convenience methods and callbacks that you can execute graph operations inside of transactions. It has support for all the query methods we encountered so far. So be it index lookups or graph traversals or Zephyr or Gremlin queries. And we also provide a fluent result handling API, because otherwise you just create lots and lots of methods in the template with the different result handling mechanisms, and we didn't want to have that. The Neo4j template also works very nicely with the Neo4j server over REST, because it can just take its methods and convert them internally into REST calls and execute them, and of course accept translation. So some examples for the template methods is callback execution up here, where I can easily create graphs. Then lookup via indexes and conversion on the fly to, for instance, to just a single property or to a different domain object or a DTO, if I want to do that. The Fluent API you can see in the to method and the single method, which allows you to specify either automatic conversions for certain things, like the actor down here or the relationship down here, and then you can have something like single or handle methods that have callback semantics. There's also a query method for traversals, one for Zephyr and one for Gremlin as well, which also take arbitrary parameters that can then be used in the query itself. As I said, it's quite important to support the Neo4j REST server, as it gets more and more used in hosted environments and cloud environments. That's quite easy, because you just use the drop-in replacement for the REST graph database in your Spring configuration and point your data graph config to that. And then the Pojo entity mapping will work with the REST client, and also the Neo4j template will work with that, and the repositories as well. So you have to keep it in mind that whenever you use something like this fine-grained Pojo mapping over REST, you have very fine-grained and chatty interactions with the server, which impact performance. That's why we rather propose using Spring Data Graph to write server extensions in Neo4j server. So we provided in initialize a class for Spring extensions or Spring plugins, which allow you to not having Spring create the graph database on its own in its configuration on startup time, but use the existing running graph database that's already running in Neo4j server and integrate with that one. And we can also choose to expose certain Spring beans as injectables for Jersey, because the Neo4j server extensions are based on Jersey dependency injection, or on a custom plugin mechanism for Neo4j server plugins. So when you write a server extensions in Neo4j server, then the goal is to provide a domain level API and protocol that exposes the right granularity for your client application to consume, so that your interaction with the server is not on the level of nodes and relationships, but is on the level of packets or bunches of domain entities that are either consumed by the server or provided by the server. So you get really good performance because all the performance critical code runs in the server, and then you transfer only the data that's needed to your client, which can use that for representation to the user or interaction with some other systems. A quick show of the cross-to persistence mechanisms. So imagine you have an existing web app that's created with Rue, I think, for managing restaurants. It's using GPA all over the place, and you want to add social networking to that. So what do you want to do? So either you can rewrite your whole app, which is quite a lot of effort, but you would remove GPA, which could be cool. You could have a completely separate data model for the social networking, so have the existing GPA-based data model separately and put on the social networking in a graph database with a complete separate data model. Then you have to synchronize between those two on your own, and have probably lots of duplication in there as well. Or another option could be to just extend the GPA data model with cross-to persistence mechanisms, so that then you have a unified data model that encapsulates all your data in the same Java class, but stores it in different data stores. So as you probably guess, we choose option C and would use cross-to persistence. With Spring Data Graph, it's quite easy to add. You could just put an annotation to that entity and then have AspectJ manage all the details of transaction and load issues and so on, and persist issues and lifecycle. So this is your JPA data model. You are probably familiar with that. Have entities, have IDs and temporal types and some relationship between the two. And so we have a user in a restaurant, and then we want to add social stuff, which is just adding a recommendation relationship between the user and the restaurant. We can also add a second thing, a friend relationship to the user account, to another user account. So then we can have really nice features like recommendation algorithms or suggestions or rankings and so on. And all this is done by just adding node entity with partial equals true as attribute to your entities, and then every property that has a Spring Data Graph annotation is handled by the Spring Data Graph library. So this nickname here, is related to, and the recommendation, the recommendations themselves are handled by the graph. We have the relationship entity for the recommendations, which not only has the start and end node, but also the comment for the restaurant and the stars I want to give it. So whenever I load the entity from the JPA provider, it is reattached to the graph database as well, and whenever I load the entity from the graph, it uses a property of the GPA ID to also load the GPA entity. So whenever you want to access any field of the entity, it's already there, loaded for you. And the same goes for persisting this data. We skip the demo for now. And as we said, Neo4j supports ACID transactions, and we have two things. We have a certain platform transaction manager implementation that uses transaction chaining, so you can have two delegating transaction managers for GPA and Neo4j, but you could also do something else. You could use existing XA transaction managers that are provided either by your J2EE server or something like JOTM or Atomicos. And Neo4j is able to use these transaction managers as well. So we can use the mechanisms to provide Neo4j with this transaction manager and have also Spring and JPA use the same transaction manager, so we don't have to do any kind of lower level transaction management on our own. But it's all handled by the XA infrastructure anyway. In the last few minutes, I'd like to speak about documentation around Spring Data Graph and some tooling. So there was a recent book by Josh Long, the Spring Developer Advocate, Getting Started with Rule. And we added a chapter to this book that covers the Spring Data Graph Rule add-on, which was the first NoSQL persistence rule add-on. The initial version of that was just using kind of a fake JPA implementation of Neo4j as an entity manager, because for a long time Rue only supported JPA-based persistence mechanism, and only late this year they added support for or abstracted the persistence mechanism and added support for non-JPA providers. And we now updated our plugin to use this new support and could get rid of all the JPA dependencies. To set up or create a simple Rue application, you would do just like that. The interesting part is the graph setup, which uses Neo4j and the database location, and then you just create your entities and add some fields to those, and then you create relationships from one entity to the other, and all that results in generating all the code and annotations that are necessary to run your application. And then you just generate the web UI and controllers, and then you're ready to run the app. We also created a comprehensive sample app with Spring Data Graph that's called Cineast.net, which is kind of a social movie database where you can have movies and their cast, their actors, and lots of data pulled from the MovieDB org. And you have users which can befriend each other and which can rate the movies, and then you can get recommendations of new movies and new friends and so on. The code is public on GitHub, and even better, we cover the development of this application in our tutorial, which is part of the Spring Data Graph guidebook that's called Good Relationships, and we are very proud that Rod Johnson and Emil Eifrem both provided forward to the book because they're really enthusiastic about the whole Spring Data Graph library. And Rod is very, very fond of that as well. And so we have the first part of the book is a tutorial through the Cineast.net application, and the second part of the book is a comprehensive reference for all the details around Spring Data Graph. And as this is also the documentation of the library, it's updated every time we change something or add something. So what are the next steps? Next steps for you is, of course, checking out Spring Data Graph, look at the guidebook, the tutorial, the examples, and perhaps the source code. And we'd love to get some feedback and suggestions and whatever ideas you have around this library. And next steps for us is we're going to present lots of content around Neo4j and Spring Data Graph at Spring One in Chicago. We will publish the guidebook as an InfoQ book, which is really cool. And we also want to provide a non-AspectJ based mapping approach that uses the Spring Data mapping facilities that are provided by Spring Data Commons. And we want to provide even better repository support, for instance, something like derived finder methods where you can just pass finder method names and generate queries from that on the fly. And we want to extend REST support to have even more means to interact with the Neo4j REST server. And looking in the near future, we also want to provide Neo4j on the client side on Cloud Foundry and Heroku. As Heroku just betaed its Java support, we can not only run Neo4j Server as a add-on on Heroku, which is already available in beta, but also Neo4j on the client side and Spring Data Graph as well, which is really interesting. So to check out some things around Neo4j and Spring Data, this slide, and we're hiring. So whenever you're ready to dive into a graph or into the rabbit hole, please take the red pill and contact us, and then we would be happy to talk with you. Okay, Adam, I think we made it almost on time.
We are almost on time. Let me tell people that I'm just going to ask one question too. But if you have questions, the best place to get them answered is the neo4j.org discussion groups. And you can go there by going to neo4j.org/community. But let me ask Michael one question that one of our Personatons has been waiting to hear the answer. What about map, e.g. hash map support in domain classes?
Yeah. Okay, that was quite interesting because actually one of the users of Spring Data Graph asked the same thing, and I pointed him to the implementation of field mapping in Spring Data Graph, and he went on implementing that on his own. So he wrote a strategy for persisting map-based fields with two approaches, either by storing them as prefix properties on the node itself, or by having a separate node that holds those properties and is related to the original node. And he's almost finished with that, and when he's finished with that, we can pull this code into Spring Data Graph, so then there will be a map support for properties of node entities.
Okay, and
So
one last question that we'll close with. Is there a Maven archetype for Spring Data Neo4j projects to get started?
Yeah, so we discussed providing Maven archetypes for that. The problem is that with a Maven archetype you get just one aspect of a project. So you can have an archetype for a web app, but then you don't have persistence, or you can have an archetype for persistence, then you don't have a web app. That's why we opted for rather going the rule way, where you can have lots of different aspects of your application generated very quickly. And probably there will be a Maven archetype, but there was no strong demand so far, so we pushed that back onto our backlog. But we have a lot of examples out there which you can just take, like Hello World examples. Take them, just replace the entities with your own, and you're ready to go. So that's not so much work to do.
Okay. Well, thank you very much, Michael, for presenting a lot of information in 1 hour. I'd also like to thank everyone who's joined us today. We understand that your time is valuable, and we appreciate the fact that you've been paying attention to us for so long. If you come up with more questions, please feel free to go to neo4j.org/community to ask them. Or if you'd like to download Neo4j, it's available as a download on neo4j.org. I have made a recording of today's webinar. I will be sending a link to the recording out to everyone who attends the webinar by tomorrow. Thank you very much. Michael, thank you.
Thank you.